Welcome to Professor Bernard's channel. This video tries to introduce the C program. Let's dive in. C programming language was developed by Dennis Ritchie and Brian Kernighan between 1969 and 1973 at Bell Labs. It was initially used as the primary language for the Unix operating system, which played a crucial role in its widespread adoption. The language first appeared in practical use in 1972. In 1988, the American National Standards Institute, ANSI, standardized the language, leading to the creation of the ANSI C standard or ANSI standard library. This standardization brought uniformity to the language's features and syntax across different platforms and implementations. The ANSI C standard includes a collection of header files, which provide essential functions and declarations for common tasks. These header files streamline programming by offering predefined functions and structures that programmers can use in their code. C programming language's success can be attributed to several factors. Designed by computer scientists for computer scientists, C was created by computer scientists, making it well designed for programming tasks, especially for those with a background in computer science. Its syntax and features are optimized for efficiency and practicality. Flexibility: C is highly flexible, capable of handling both high-level and low-level programming tasks. This versatility allows programmers to write code at various levels of abstraction, making it suitable for a wide range of applications. Direct memory manipulation: like low-level languages, C enables direct manipulation of memory, which gives programmers fine-grained control over system resources. This capability is essential for tasks such as device drivers, operating systems, and embedded systems programming. High-level language features: despite its low-level capabilities, C also offers high-level language features such as functions, data structures, and dynamic memory allocation. This makes it easier for developers to write complex programs while maintaining efficiency. Portability: C is usually the first language ported to new processor architectures. Its widespread availability on various platforms and its portability make it a preferred choice for system programming tasks where hardware-specific optimizations are necessary. Systems programming: C is particularly well suited for writing systems programs such as operating systems, compilers, and utilities due to its close-to-hardware nature and efficiency. Foundation for C++ and Java: C++ compilers have a C compiler as their core, meaning C serves as the foundation for C++ and inherits many of its features. Additionally, Java, one of the most widely used programming languages, was originally written in C, further emphasizing its importance and influence in the programming world. The process of compiling a C program involves several stages. Writing source code: the programmer writes the source code of the program in a text editor or an integrated development environment, IDE, such as Visual Studio. Preprocessing: the source code is processed by a preprocessor program, which interprets directives such as #include, #define, and #if. The preprocessor copies any header files included in the code and replaces symbolic constants with their values. Compilation: the preprocessed source code is passed to a compiler program. The compiler translates the C code into assembly language specific to the target processor. This step generates assembly code files, .asm or .s. Assembly: the assembly code files are then processed by an assembler, which converts them into pure binary code or machine code, known as object code. The output of this stage is one or more object code files, .obj. Linking: the linker program takes all the object code files generated in the previous steps, including any library functions used in the program, and merges them into a single executable file. The linker also resolves any references to external functions or libraries and links them to the appropriate locations. Additionally, it combines the necessary machine code for any runtime library routines. The final output is an executable file. exe This is a simple C program that prints "Hello World" to the console. Here's a brief explanation. This is my first program. This is a comment. Comments are ignored by the compiler and are used for documentation. #include studio.h. This line includes the standard input-output library, studio.h, in our program. This library provides functions like printf and scanf, which are used for input and output operations. Int main. This is the main function. In C, every program must have a main function, and the execution of the program starts from here. Int is the return type of the function, which indicates that the main function will return an integer. Main with no parameters indicates that this function doesn't take any arguments. Opening curly brace signifies the beginning of the function body. Printf "Hello World." This line prints "Hello World" to the console. Printf is a function from the studio.h library used for formatted output. "Hello World" is a string literal line closed in double quotes. Return 0. This statement indicates that the main function has finished executing and returns an exit status of 0 to the operating system. This conventionally signifies successful termination of the program. Closing curly brace marks the end of the function body. Escape sequences in C are special combinations of characters that are used to represent non-printable characters or to perform formatting within strings. Here's some of the escape sequences and a brief explanation of each escape sequence. \n, new line character. This escape sequence moves the cursor to the beginning of the next line. \t, tab character. It inserts a horizontal tab, typically advancing the cursor to the next tab stop. \r, carriage return. This moves the cursor to the beginning of the current line without advancing to the next line. \, inserts a / character. \, single quote, inserts a single quote character. Double quote, inserts a double quote character. These escape sequences are often used in C strings to represent characters that cannot be easily typed or displayed directly, or to perform specific formatting tasks within the text. This program shows how escape sequences are used. Here's a brief explanation. // created by Bernard Ugalde. This is a comment. Comments are ignored by the compiler and are used for documentation. #include studio.h. This line includes the standard input-output library, studio.h, in our program. This library provides functions like printf and scanf, which are used for input and output operations. Int main. This is the main function. In C, every program must have a main function, and the execution of the program starts from here. Int is the return type of the function, which indicates that the main function will return an integer. Main with no parameters indicates that this function doesn't take any arguments. Opening curly brace signifies the beginning of the function body. Printf London \n. This line prints the string London followed by a new line character \n, which moves the cursor to the beginning of the next line. Printf \t Ontario \n. This line prints the string Ontario preceded by a horizontal tab character \t and followed by a new line character \n. Printf, single quote Canada, single quote. This line prints the string Canada with single quote before and after the word. Return 0. This statement indicates that the main function has finished executing and returns an exit status of 0 to the operating system. This conventionally signifies successful termination of the program. Closing curly brace marks the end of the function body. As a recap, C programming language was developed by Dennis Ritchie and Brian Kernighan between 1969 and 1973 at Bell Labs. It was initially used as the primary language for the Unix operating system, first appearing in practical use in 1972. C's success is attributed to factors like being designed for efficiency by computer scientists, its flexibility for both high-level and low-level tasks, and its capability for direct memory manipulation. C is often the first language ported to new processor architectures and is suitable for systems programming due to its efficiency and close-to-hardware nature. C serves as the foundation for languages like C++ and Java, with C++ compilers having a C compiler as their core, and Java itself being originally written in C. Compiling a C program involves stages like writing source code, pre-processing, compilation, assembly, and linking, resulting in an executable file. C escape sequences are special characters used to represent non-printable characters and perform formatting in C strings. That's all for this video. See you in the next videos for more C programming topics.